Hey guys, so today we're gonna talk about something interesting. Even the most novice of stargazers are aware of two important facts regarding our universe. First, it's unfathomably large, and second, it's also a vacuum. A quick Google search for the definition of vacuum will tell you that it is a space entirely devoid of matter. While it's true that outer space is more devoid of matter than any vacuum found on Earth, it is actually not entirely devoid of matter. In fact, there is a name for this natural phenomena, the interstellar medium. But what exactly is the interstellar medium and what does it have to do with the nebulae? Let's dive in to find out. So, in a nutshell, the interstellar medium is the material that fills the space between stars. Approximately 99% of the interstellar medium is composed of interstellar gas, and of its mass, about 75% is in form of hydrogen, either molecule or atomic, with the remaining 25% as helium, and the rest is composed of dust. Interstellar dust is not like the dust that you might find under your bed. It is made of very different substances. These dust particles are extremely small, just a fraction of a micron across, which happens to be approximately the wavelength of blue light waves. The particles are irregularly shaped and are composed of silicates, carbon, ice, or iron compounds. The interstellar medium is vast and expansive in size, but very low in density. For comparison, the air we breathe has approximately 10 million trillion molecules per cubic centimeter, while some of the lowest density areas of the interstellar medium consist of approximately zero point 0.1 atoms per cubic centimeter. In other words, imagine a hollow ball the size and circumference of the Earth. Now, imagine placing a couple of liters of gas into this hollow Earth-sized object and allowing it to spread evenly throughout. And that's how low in density the interstellar medium is. But wait, since our universe is so vast, the total mass of the interstellar medium within any given galaxy adds up substantially. In our Milky Way alone, it is estimated that the interstellar medium makes up between 10% to 15% of all visible mass. In some instances, matter within the interstellar medium can coalesce and collapse under the force of gravity, creating nebula in the process. So you might ask, some gas in space, what is so cool about that? Why is interstellar space important? Well, it is cool, because the interstellar medium is where stars are made. Without it, we wouldn't exist. If there weren't thick and thin spots that condensed into thicker patches that eventually became stars, the whole universe would just be a cloud of boring, cold, lifeless gas. The first stars didn't have any planets because there weren't any materials in interstellar space beyond hydrogen and helium. But over the billions of years of our universe's history, that has changed. A stream of charged particles emanates from the upper layers of the sun's atmosphere. This stream of particles is known as the solar wind. The sun and its solar wind create a kind of cavity that envelops our entire solar system known as the heliosphere. The heliosphere is like a balloon with a sun and planets inside the balloon. Outside the heliosphere is interstellar space. The heliosphere is moving through the space of our Milky Way galaxy. As it moves, the part of the heliosphere that faces the center of our galaxy receives more pressure than the side that faces away. So the heliosphere is stretched out into a teardrop shape. Once you've traveled past the inner edge of the heliosphere, there is a region called the termination shock. That is like whitewater rapids in a stream. Finally, it smooths out and you enter the heliopause, an area where the internal pressure of the sun's effect balances with the outside pressure of the interstellar medium. It's very still, where you finally enter interstellar space itself. Astronomers estimate that the total mass of gas and dust in the Milky Way galaxy is equal to about 15% of the mass contained in stars. This means that the mass of the interstellar matter in our galaxy amounts to about 10 billion times the mass of the Sun. There is plenty of raw material in the galaxy to make generations of new stars and planets, and perhaps even astronomy students. The Voyager 1, which is the first spacecraft to reach interstellar space, it originally launched in 1977 to explore the outer planets in our solar system. However, it has remained operational long past expectations and continues to send information about its journey back to Earth. NASA's Voyager 2 is the second spacecraft that joined its twin Voyager 1 as the only human-made object to enter the space between the stars.